finish today the second collab on Cloud Run. So I let Mete take care of this, and then afterwards there's going to be another Cloud Run service, and then the front-end web application. I'm going to stop presenting and let Mete take the mic.
Can you hear me okay?
Yes.
Great. First, let me just paste some links for people. So if you were here yesterday, you have all these links, but just in case, I will paste them again. So we have the Collab page, we have the credits. So we have credits for the workshop that you should have received yesterday. But if you weren't here yesterday, you can go to that link to get credit for the workshop. Then Google Cloud Console link, and then we have the code and the presentation already online and public. So if you want to get to them after this presentation, you can. And let me just share the presentation so we can go through like what we did yesterday, and then we can continue with where we were left off. So let me first open my present. All right. I guess you can see my screen, right?
Yes.
Okay, good. So we started building the serverless photo sharing app. And in this app, what we are trying to do is users come to this page, which is powered by App Engine. They will upload a picture, and then we will extract the labels of these pictures using Vision API. So all the labels that you see underneath the pictures, they're actually extracted by Vision API using machine learning. We also extract the dominant color in the picture and put a border around the picture with that color. And then we have nice things in this app, like, given a bigger picture, we make a small thumbnail out of it. So these are thumbnails. And then we also create a collage of 4 thumbnails. So once you upload 4 pictures, we'll get them together into this nice thumbnail. So what we did yesterday, and this is the architecture. So for the architecture, we're going to have an App Engine front end. So this is what we're going to build today. But then what we did yesterday is that we created the bucket. So we created a pictures bucket to actually store the pictures. Then we created a cloud function that does the image analysis using Vision API. So whenever someone saves a picture, it triggers an event, and this does the analysis and save the results of the labels into not data store to Firestore. We're going to update this picture in the next edition. And then the second service that we started working on, so this was lab 1 that Guillaume worked on. And then I started looking into Cloud Run and start building a thumbnail service. And this one would basically, every time someone saves a picture, it will get a notification, and then it will create a smaller version of the image. Now, this notification in Cloud Run happens a little bit differently from Cloud Functions. In Cloud Functions, if you remember, as we created it, we just said, okay, this is the bucket I want, and this is the event I want to receive, and everything was set up for us. Cloud Run, it's a new product, so all the plumbing is not set up yet automatically for you, so you have to actually set that plumbing yourself. So what happens in this case is that when you save a picture, you want the cloud storage bucket to send a notification to PubSub, and there's a way to set that up. But we haven't done that yet yesterday. And then once that notification goes to PubSub, we want PubSub to send a push request to the thumbnail service. So you have to set that up yourself as well. So you have to do those 2 steps yourself. And once that's done, every time something is saved here, you would be able to get that notification in thumbnail service, and then you would be able to save it to another bucket. So what we did yesterday is we just deployed the thumbnail service to Cloud Run, but we didn't create this pops up topic. We didn't set up the notifications from storage to pops up, and then we didn't do the push from pops up to thumbnail service. So that's what we're gonna do. Now, in terms of, I don't know if all of you were here yesterday, but if you weren't here yesterday, it won't be, I guess you can watch and then try to do the labs yourself later if you want. But if you want to do it. Another option is that you can try to quickly go through lab 1. I mean, the important thing in lab 1 is basically to create this bucket, the pictures bucket, because that's what we want to listen to notifications from. So even if you don't create this image analysis function for now, like you can create the bucket and then continue with the thumbnail service. But then you also need to create the image analysis at some point, because that will save some metadata, and then we're going to use that metadata from Collage service in the next lab. So yeah, that's where we were. I think there's something in the chat. Let's check. Someone says, I came from zero GCP background. Can I know online diff between run and function? Yeah. So what's the difference between Cloud Run and Cloud Functions? In a nutshell, Cloud Functions allow you to deploy functions. So you just create a function and then just say deploy this function, and everything is done automatically for you. Whereas Cloud Run deploys containers. So you need to define a Docker file for your app. So you need to containerize your application, and then you deploy that container. Now, when you look at the features, both Cloud Run and Cloud Functions, they provide similar functionality in the sense that, once you deploy your function and once you deploy your container, they are automatically scaled. The traffic is set up for you, and they have this event-driven kind of features that you can set up. So at the base level, they do similar kind of functionalities. One is a function, the other one is a container, and then the other important difference is that in Cloud Functions, what you can do is limited. So the number of languages you can use is limited. Like you cannot use Node.js, Python, Java, and Go. Whereas in Cloud Run, it's a container. So anything that you can run in a container pretty much can run on Cloud Run, as long as it's in a stateless type of container. So that's the reason why people usually go with Cloud Run instead of Cloud Functions, because it gives you more flexibility in terms of what you can run. For example, for me, I'm a C# developer, and my default place to go is Cloud Run, because C# is not supported on Cloud Functions yet. So that's my reason to use Cloud Run. But different people have different reasons. So that's a good question. Yeah, that's it in a nutshell. Let me see. There's another one, I guess. Oh, Dave. Okay, thanks. Cool. And I think that's it in terms of presentation. Yeah. So we did the first lab, lab 1, and then we were in the middle of second lab. So let me switch to my console. So this is the code lab page, and then let's go to lab 2. And I will just step through this until to the point that we were left off, and then we can continue from there. So to recap, in this lab, let me make this a little bit bigger. In this lab, what we want is user says a picture to the bucket, and then that will trigger a pops up message to a topic, and then that will do a push call to thumbnail service, which is going to be a Cloud Run service. And then once we get the notification, we will resize the image, and we will save to another bucket. It's not going to be the pictures bucket, it's going to be thumbnails bucket. So we are basically resizing the image. Now, to do this in Google Cloud Console, we'll go to...
Can you please zoom a little bit, Mete, so that, because it's barely readable in terms of size. Thank you.
The console, you mean?
Yeah, and yeah. So,
okay.
Yeah,
is this
better.
Yeah.
Thank you.
And then how about this one? Let's make this a little bit bigger too.
Yeah, this one too.
It's good?
Yeah.
Cool. Thanks. All right, so to do the lab, we went to Google Cloud Console, and then we are using Cloud Shell. So if you click here, you are in Cloud Shell, and everything you can do it in the browser. You can also install Google Cloud SDK and do this locally if you want from your own terminal. But I usually prefer using Cloud Shell because it's easy. I'm in the browser, I just click, and then I have my environment here. So we did this yesterday. We enabled the APIs. So two things that we needed was the cloud build, because we're going to be building Docker images. So for that, we need to make sure that Google Cloud Build is enabled. And then we also want to enable Google Cloud Run, the service that we want to run. So we did that yesterday. If you haven't done it, make sure they're enabled. Then we want to create a bucket for the thumbnails. So once we resize the images, we want to save them. So for that, we use this convention in our bucket names. We want to make sure that our bucket names are unique. So what we are doing is that we are calling it thumbnails dash, and then we attach our project ID, which is unique to it. So this way we are making our buckets unique. So I think I should still do this because I'm going to need this. And then if I do thumbnails, it should be there. And then let me make sure that I actually did create this yesterday. So if I go to storage, you can see that I have one bucket called uploaded pictures. So this was the first labs bucket, and then second one is thumbnails bucket that I created yesterday. So you should also have those. If not, then please create them. Then we basically created our bucket in Europe, and then we made sure that it's a public bucket. So you should see the public public access near your bucket. Then we clone the code, and the code for thumbnails is under services thumbnails. Then we went through the code. So these are the dependencies, the Docker file, and just to show it quickly, I just want to show you the part that we actually do the thumbnail stuff. So if you go to services, thumbnails, under index, this is the code. So what we are doing is that we're receiving pop-up messages, and these messages are base64 encoded. So we kind of decode that message first. Then we get the from the event, we get the bucket that generated the event. In this case, the images, the pictures bucket. And then we pass in the thumbnails bucket through an environment variable. Because we want to, as we start the service, we'll tell the service, this is the bucket you should use to store your thumbnails. So that's what we are reading here. We are reading the bucket thumbnails environment variable. Then here is the magic for resizing. So we are using image magic. So first we download the images into the container. Then we use image magic to resize them. Resize it, actually just one picture, and then upload it to the thumbnails bucket. So as you can see, it's very self-contained, easy code. So we did this yesterday, and then we tested locally, so it should still be the same. Then we need to build the image and store it to Google Container Registry. And we did this with gcloud. So if you do gcloud build submit, and then tag your image, then this will go to Google Container Registry under thumbnail service. Let's make sure that it's actually there. So if you go to Container Registry, yeah, you can see that under here there's a thumbnail service. And then here we created this 22 hours ago, which sounds right, towards the end of the lab yesterday. So we have it there. And finally, we can deploy. And to deploy, we ran this command, gcloud run deploy, give it a name, thumbnail service, point to the image that we pushed. The platform is managed, because Cloud Run has two different versions, the managed version that we are using, and there's also a version that runs on GKE. So if you are using that one, you wouldn't say platform managed, you would say, I think it would say GKE or Anthos here. Then your region, then make it public. I mentioned this yesterday. you don't need to make the service public actually, because it's an internal service that will receive notifications from PubSub, and it doesn't need to have a public endpoint. PubSub can still call internal endpoints, but for this lab we are making it public. You don't have to do that. And then we're giving it 1 gig of memory, because by default it has 250 megs. So we are just giving it up a little bit more memory. And then we are passing it an environment variable that's bucket thumbnails, and we are passing the bucket thumbnails, the name of the bucket that we created. So this is how we are telling this service where to save the images. So I think we did this already, and then we were left off at step 10, but let's just look at our Cloud Run service now. So if we go to Cloud Run, the service is here. And the nice thing about Cloud Run is that, first of all, you get this console with some graphs. I mean, no one is using our service right now, so you don't see anything. But by default, you get a good kind of overview of how your service is behaving. So that's nice. Then in Cloud Run, there is this notion of revisions. This actually comes from App Engine. In App Engine that we're going to talk about next, there's also this notion of revisions, where every time you deploy a service, it gets a new revision. So if we deploy this service, like say 3 times, then we would have 3 different revisions here. And then once we have multiple revisions, you can actually do traffic splitting here. So if you click the manage traffic, you can do, like, say 90% of the traffic goes to this revision and maybe 10% goes to the new revision. So this way you can deploy a service, and then you can do kind of A/B testing, or like gradually ramping up traffic. So it's very useful for that kind of stuff. There's also integration with Stackdriver for logging. So you can either go to log viewer. So if you remember from yesterday, if you go here and to logs, I won't show it here right now, but there's a separate section in Google Cloud Console to see the logs. But you don't have to go there. You can also see it from here, and you can see that our service is being created, and then it's running on port 8080. So you can see the logs here. But if you need to do searches and more complicated log viewing, then you need to go to log viewer and then do it from there. And if you look at the details of the service, this tells you whether it's an external service, whether it's authenticated, where it's deployed, things like that. And interestingly, if you look at the YAML, you will realize that this is a service, and the API is Knative. So this is actually a Knative service. And I mentioned this yesterday. Knative, it's an open source project to run containers in a serverless way on Kubernetes, right? So if you have Kubernetes running on-prem, or if you have it running on Google Cloud or some other cloud, you can install Knative, and you will have this kind of features that I explained, but on Kubernetes itself. And Cloud Run, even though it's a managed service, it's implementing Knative. And you can see this from this YAML, that this service is actually a Knative service. It's getting all of the traffic. So all of this comes from Knative, which is nice, because what you can do is you can actually take this YAML and deploy this service to a Knative on Kubernetes running locally, if that's what you want to do. So it's good that things are based on open source projects, and you're not really tied into using this service just on Google Cloud. So this is a quick overview of the service, and usually in the lab, we are deploying things from command line. We are adding environment variables from command line, but you can do some of that from the UI as well. So if you go to here, edit and deploy new revision, you can see which image you're pointing to, and you can change that if you want. You can see the port you're binding into, and there's some things that you can change. For example, I mentioned yesterday that Cloud Run can handle 80 requests concurrently, but you can change that from here to something less, or I think less, because I don't think you can change it more than 80. The request timeout is how long your requests can last, and I think maximum is 900, but that can be changed as well, 900 seconds. You get 1 CPU by default, but you can change it to 2, and we'll probably increase that later. Max memory is 2 gig. We are choosing 1 gig here right now. Auto scaling can be changed. So by default, it scales up to 1,000 containers. But if you don't need that and you want to keep the cost down, you can set this to a lower number. And that's it really here. And then we can also look at the variables. So remember when we deployed our service, we declared bucket thumbnails and pointed to our bucket value. So that's what we are seeing here. But you can also add other variables here. One thing to note is that every time you change something about your service, you have to deploy again. So that will deploy a new revision. So the configuration changes, you can't just apply them on the fly. And I think that's a good thing because it's a change in configuration. I mean, whether it's a change in configuration or a change in the code, it's a change, right? So you need to deploy a new revision and then see if it works. And then with that revision, if there's something wrong, you can easily roll back to the previous revision. So the fact that you need to deploy every time there's a change, I think it's a good thing. And you can also connect to things, like say if you have Cloud SQL connections, if you want to connect to Cloud SQL, you can add a connection here. We should probably note that Cloud Run, it cannot access to everything yet, but we are adding access like as we progress. So Cloud SQL is one of them that we are adding. I think there's a new one, like for example,
the VPC. Yeah, and the VPC connector is in beta, I think. So if you want to join or access stuff that is on the VPC that you created, you'll be able to do some of this.
Right. So we are basically like adding more and more services so that you can connect them from Cloud Run. But it's something to check. If you want to deploy something to Cloud Run and you'll know that you want to connect to some services, make sure that you can connect to them before you actually start the project. It's a good idea to check because it's a new product and things are not there yet 100%. Okay, so that's Cloud Run. Now let's go through the connection part of from bucket to PubSub to Cloud Run. We got this for free in Cloud Functions, but actually we have to do this plumbing ourselves right now. So we need to first define a number of variables. So the first one is topic name. This is the PubSub topic that we're going to use to do the connection from the bucket to our service. So that's the Google Cloud PubSub topic name. Then we need our project number for later when we need to create a service account. The service name, we call it thumbnail service. Then you can get the service URL using this command, and we were going to get it and then assign it to service URL because we're going to need that as we set things up. The service account is the account that will make the call from PubSub to Cloud Run. So there is a name for the service account, and we are basically just saying it's topic name -SA service account. And finally, we need to know the pictures bucket because we need to enable notifications on the bucket to send messages to PubSub. So that's why we are setting that here. I think if I just copy and paste this, it should just work, but we'll see. I will go back to my terminal. Right, and I will just double check the topic name and the, so let's just double check, make sure that the topic name is set, and then let's just double check. I'm always making sure I don't trust computers. Yeah, the service URL is set, so I think it looks like maybe I also check the last one, bucket pictures. Yeah, that's there as well. So okay, these are all set, good. Now, first we need to create the PubSub topic. So this is, you can do it from the UI, but I like to do things from command line. So this will create the bucket. Now, there's going to be lots of back and forth between Collab and Cloud Shell. So this created a PubSub topic. Then we want to enable notifications on the pictures bucket, so that every time there's a change in the bucket, it sends a notification to the topic, right? So this is what we are trying to do here using GSUtil. We are enabling notifications on the bucket, and it will send the pops up message to the topic that we just created. So let's do that. All right, so that worked as well. Now, next, you need to actually create a service account. So in Google Cloud, everything happens through service accounts, and in this case, we want PubSub to make a call to Cloud Run service, right? So for that, we need a service account, and that's what we are creating here. So you can obviously choose any name and any display name you want, but in this case, we are calling it GCS-events-SA for service account. And then you need to give this service account the permissions to actually invoke your service, right? So you do that by adding a IAM policy binding. And again, all this stuff can be done from the UI, but it's good to do it this way, I think. And what I usually do is that I usually create scripts for my setup, so that next time I come in, I can just run the script and it just does everything for me. So this gave the permission for the service account to call my service. And then finally, pops up to create authentication token. So we need to set this up as well. To be honest, I'm not sure exactly like what it means, authentication tokens. I think when the Cloud Run receives the call, it will check that there's an authentication token, and I think that's what this does. Like it makes sure that the PubSub can create those authentication tokens. But I'm not 100% sure because I just followed the documentation from Cloud Run, and this is what they tell us to do. So that's done as well. And that's a lot of steps, by the way. But then finally, we need to create a subscription. So we have the service account, but we need to create a PubSub subscription for the service account. And this subscription is the thing that will actually send the message from PubSub to our service. So you can see that the subscription has a name. So we use a topic name -subscription as a name. Then it's a subscription of a topic. So this is the topic that we are using, the one that we created. Then we can tell this subscription what to do. So what we are saying here is that this is our endpoint that we want to call. So when this subscription receives a message, it will make a call to our Cloud Run service. So that's why we have the service URL that we got from before. It is the URL of Cloud Run service. And then Cloud Run will check for the service account. So we are also saying that, okay, when you make this call, make sure you are using this service account. And this service account is the one that we just created with all right permissions and everything. So let's copy and paste that as well. And again, like in Cloud Functions, this happens all behind the scenes. I'm sure it's similar things that happens behind the scenes. But in Cloud Run, we have to do it ourselves. Okay, the subscription is created as well. And I think this is it. Let's just double check that actually the subscription is created. So if we go to PubSub, I should pin this. So if we go to PubSub, and under topics, we should see our topics. So this is the topic for Cloud Builds. That's there by default. GCS events is the topic that we created. And then if you go down here, you should see under subscriptions, we have a GCS event subscription. And then I think if you click on that one, we should see, I mean, if this is being used, you see some data here, but then you can also see that it's push and the endpoint is our thumbnail service endpoint. So it seems like everything is set up, but it's always good to double check. And then you can also see that this is the service account that's being used, which is good. All right, so hopefully people got set up. I still also chats, but I'm assuming Guillaume, is everything okay? Like, do I need to answer?
Everything is okay. I'm giving
okay. If I need to answer or slow down or stop, let me know.
Sure.
Otherwise, I'll just keep going.
No problem.
Cool, thanks. All right, now it's the time to test. Let's see if things work. So what we're gonna do is we're gonna upload a picture to the pictures folder, and that should trigger actually 2 events, I guess. One event is gonna go to the first function that we deployed that will do the image classification and save it to Firestore. And the second one will go to our thumbnail service, and it will resize the image and save it into thumbnail bucket. So let's see if it's gonna work or not. So I'll go here to storage. Then upload the pictures. So yesterday I only had 1 picture here, which is a beach picture. But today let's upload more. So now I have this river picture, which is near where I live. So let's upload that. So let's upload it, and if everything works, so now if we go to Cloud Run service, hopefully I should see something in the logs. So let's wait for the logs. Yes, it looks like something's happening. So our service was started. Then it says it received the pops-up message with these attributes. Then we base64 decoded the event. Then we are saying that, okay, we received the thumbnail request for this image, which is river.jpg. That's the image that I uploaded. And we downloaded it into our container, then resized, then uploaded, and let's check. I mean, this is telling us that it worked, so let's just double check. Go back to storage. And if you look at thumbnails, you can see that the river is there. And actually, let's take a look. You can, yeah, this is the image, but it's a smaller version of it. So it seems like it's working, which is great. Now, for the next service, I'm going to need at least 4 pictures. So now let me upload. Actually, let's re-upload this first picture because I want to have a thumbnail for that one as well. So let me re-upload this, and let's see. I mean, I think the service should work for pictures that's been overridden, but we'll see. So I will just replace existing object. Okay. So that's uploaded, and then let's upload a picture of me. And then I'm going to upload another one. All right. Now let's go back to thumbnails. And I can see that there's 4 of them. So if we open this one, it's a smaller picture of the yacht club that's close to my house again. And beach is another beach picture. And then this should be me. Yeah, so they're all there. And let's also, before we move on, let's also make sure that Firestore is also working. So the first service that we deployed, it also still works. So if you go to Firestore, you can see that we have the pictures collection, and now we have 4 documents. The first one is me, and then these are the labels, and it's created and color. Same for the second one, third one, and fourth one, which is good. So it looks like we have all the stuff that we needed. Now in the next lab, we're going to use the creation time, and I don't know if you're going to use the color here, but we're going to use the creation time, and then in the last lab we're going to use the actual dominant color of this picture to do something interesting. So cool. This concludes lab 2. I think I'll just pause here for a second before I continue. Has there been any questions that has not been answered yet? Okay, it looks like we are answering the questions. People, if you can give some indication, did this work for people, or if people can just post on the chat that it's working or it's not working, I think that will give us a good indication on how things are progressing. So who got the service working? The two services working? Anyone? Okay, Guillaume, of course, he had it working. Oh, someone did it yesterday. Okay, cool. All right. Now let's go with the third lab, which is going to be another Cloud Run service, and the fourth one will be an App Engine service. All right, go to overview. So we have our bucket, we have our image analysis service, we have our timeline service, and now the third service that we're going to write, it's a collage service. What it does is that it will run on a schedule, so it will run once in a while, and this schedule will be triggered by Cloud Scheduler. Cloud Scheduler is Google Cloud service that basically it can make a call to a bunch of different things on a given schedule. And one of those things is it could be Cloud Run. So what we're going to do is we're going to set up a Cloud Scheduler. It will make a regular call to Cloud Run service. And this Cloud Run service will go to the thumbnails, I think, bucket. And it will look at the last 4 uploaded pictures. And the way it will find those last 4 uploaded pictures is that it will query the Firestore database, and it will look at the creation time, and it will get the 4 last pictures from there. Then it will fetch them, and it will fetch the thumbnails, and it will put them together into a collage, and it will save it back into the pictures bucket, I think, if I remember correctly. So that's the service. We can skip the setup and requirements because we are already in Cloud Shell. But as always, we need to enable the APIs. In this case, we already have Cloud Run and Cloud Run build, so that's already enabled. But we need to also enable Cloud Scheduler, which is the thing that will call our service. By the way, you might be wondering, like, why do we need to do this on a schedule? We don't have to do it on a schedule. I mean, we could have done it so that maybe when someone uploads a new picture, we get a notification, and then we can go to Firestore and find the last 4 ones and then create a collage. We could have done it that way. This is just to show you that there are different ways to invoke your Cloud Run service, and Cloud Scheduler is one of them. So in this case, we chose to go with that, where we just don't care about events or anyone uploading pictures. We just on a schedule, grab the last 4 and deploy, and then work with those. So just another way of invoking the service. But there's many different ways of doing this. All right, so let's first enable our service, the scheduler service. All right, so that's enabled. Then if you don't have the code, please get the code. But we already have the code, and we're going to explore the code. I guess I can show it from editor again. It's going to be very similar to the code that we had for the previous service. So the way events come in and the way we read thumbnails and all that will be very similar, but then we're going to do a little bit different things in the code. So let's just take a look. So the Docker file, I think it's pretty much the same Docker file. There shouldn't be any difference here. Now, the index.js, the main file, is that it's using the same library. So we need to access cloud storage. We need to access Firestore. And then we are using the same things like Express for the web framework, promises, ImageMagick for image manipulation. So all of that is the same. When a post request comes in, we get in here. The first thing that we do is we look at the pictures collection in Firestore, right? And then we order by the created timestamp, and then we get the for the last 4, I guess, by creation time. Now, I guess if you have less than 4, then it's gonna say something like empty, no collage, or something like that. And then there's probably other issues like we're gonna be reading from thumbnail. So if someone kind of sneaks on you and deletes them, then that can be an issue. So this code is by no means is production or anything like that. So there's all these edge cases. But if everyone behaves and then you upload the pictures and you don't sneak and delete them, it should just work. So if we have pictures, we first, let's see, we get the names from Firestore. So the Firestore has the pictures names. The picture names are the ID of each document, right? So we get it from there, and then we go to the thumbnails bucket and kind of grab those 4 pictures that we got from Firestore. So this is downloading the pictures from thumbnails bucket to our local container. And then once we have that, we are using this image magic code. Guillaume, maybe you can explain this part, because I don't know what this code does.
Yes, so this is, I guess, the trickiest part, and it took me a while to get it running. So it's a pretty magic command using image magic to create the collage of pictures the way we want. That is, how to say that? 2 pictures by line, basically. So it's I just read. So we have the collection of 4 pictures. We use the curly brackets. We get the first 2 pictures. Then we have to do plus append. It's a really weird command line that you have to run as well when you're exploring with the image magic tool. Append is going to create a new line, basically, to append the pictures on the next row. So that's why we have a very, very strange command there.
Okay. But it works. I mean, you'll see it once we run it. So we do that, and then this will give us a single picture that we save in the container. Then we upload to the bucket, and that's it. So okay. So I guess we are uploading back to the thumbnails bucket. So in the same thumbnails bucket where we have the 4 pictures, we're uploading the collage in there as well. So as you can see, like, other than this image magic code, the rest of the code is pretty much the same. But then what you're doing, like, after the event is a little bit different. But yeah, this is what we do.
And I agree that the error reporting could have been better.
Yeah, I mean, there's a lot of edge cases that stuff can go wrong, but
it would make the code more
production-ready code.
Yeah, and it would make the code more complex also to explain if we do proper error handling. So that's why we simplified it a little bit.
Right, you're just giving people hints on how to do things. All right, so that's the code. I think I covered pretty much everything in here. Yeah, let's just again run this just to make sure that I didn't because sometimes I get in here and add a weird command without realizing, and then I try to build the container and then something doesn't work and I'm trying to figure out why. So it's always a good idea to just run it locally, quickly, make sure that it's actually working, or at least it starts. So let's go to services, and this is Collage. And then let's just make sure that it actually starts. Yeah, but it does start. I'm not going to test that it actually works, because you need to set certain things to make sure that it works. But I can trust that it will actually build. So that's good. And just like before, we need to build the image, and we need to save it to Google Container Registry. By the way, you can also use Docker You can build in Docker, and you can use Docker push to Google Container Registry, and that works as well. So if that's what you're used to and that's what you want to use, yeah, you can do that. But a single command is better than 2 commands, and I also like to build using Google Cloud Build rather than relying on Docker and Cloud Shell to build. So that's why I use this one. And actually, let me double check that Google Cloud Project is set, because sometimes Google Cloud Project is not set. I don't know. I couldn't figure out when it's set and when it's not set. But it always pays to double check.
It's a mystery.
Yeah. So this will upload things to the cloud, and it will build using Google Cloud Build and save it to Container Registry. So let's wait for that to happen. In the meantime, if you have any questions, please let us know. And we should be able to see this under Cloud Build as it's building. If you look at Cloud Build, yeah, you can see that this is the build that we did yesterday, and then this is the build that's happening now. And you can see what's being run, which steps. I usually don't follow this because everything is streamed here, so I can see it from console. But it's nice if something goes wrong, you can come here and take a look in more detail. Yeah, it seems like things are being pushed. So yeah, it's done. So let's just double check quickly. Go to Container Registry. I should. There. And now we should have two separate places. The Collage service is the one that we just deployed. So yeah, you can see that the image is just deployed. Now we can deploy this to Cloud Run. It's exactly the same as before, except we are passing in the bucket thumbnails because that's what the code expects. So let me make sure that I actually have this. I should, but I will just do that again. And then gcloud run deploy. Again, in this case, it could be a private service because Cloud Run Scheduler also can call internal services, but we made it public. Maybe we'll change this in later editions of the workshop and make it private because it doesn't really have to be public, and it's always good to make things private if they don't need to be public. But let's just keep it as it is now.
Actually, it's private. It's no allow unauthenticated, so it's a double negation, so it's private, right? Because otherwise it's only allow unauthenticated. There it's no allow unauthenticated.
So right. Yeah, I missed that. Yeah.
So I guess we could have skipped it
okay.
to have it by.
So if you don't put this, it's by default it's private.
It's private, yeah.
Okay. Cool. Yeah, that's a good point. Yeah, I mean, no allow unauthenticate. It's like double negation.
I hate double negations.
Yeah, the service is deployed, and actually we can see if it's public or not from here. So let's just double check that. Yeah, so it is private. That's true. So you can see the URL. There's a URL here, but then you cannot click on it because this is not a public URL. And actually, this tells you how you can call this service, because the service expects an authentication token, and gcloud can give you this authentication token, so you can actually run this command and still test your service yourself. But people from outside, they cannot call your service because they don't have this token. So that's good. It's private. And if you check, let's just double check the logs. Yeah, it's running. Now, again, in Cloud Run, we don't have the UI yet to just drag and drop and say, okay, this is Cloud Scheduler. I want to call this Cloud Run service, and everything is set up for you. So you have to go through the setup yourself again. So that's what we're going to do next. So in Setup Cloud Scheduler, again, it's the same kind of setup as pops up. We need a service account. This is our service name, and this is our service URL. So these are the things that we need. I didn't export these, but it should still work. So let's clear this. And again, let me double check, because I never trust computers. Oh, and then let's also check the service URL. That's Collage service good. Now, we need, just like before with pops up service, we need a service account for scheduler. And then for that, we'll call it Collage Scheduler Service Account. All right. And then we need to have this service account permissions to call our service, just like before. And then we need to set our scheduler, right? In this case, we are setting it to run every 1 minute. And then we are saying that every 1 minute, we want to make an HTTP post to this URL. And this URL is our Cloud Run service URL. And then this is our service account. And you need to also set this token audience, meaning I guess this says that this service account can only call this service URL, which is a Cloud Run service. Again, there's a lot of like IAM, the authentication details here that I don't know much about. I just know that I need to have a service account, and I create it, and then just when I create the scheduler, I associated it with the service account, and then it works. But under the covers, I don't know the details of, like, for example, the audience. If you don't set it, would it work or not? I'm not totally sure, actually. I think you need to set it, and that's why we have it here. But let's just copy and paste this. That was quick. Let's make sure that the scheduler is actually set up. So if I go here, Cloud Scheduler. Yeah, so there's a Cloud Scheduler. It's enabled. It has not run yet. And there's a Run Now button that I can actually run. And let's see what happens. I just run it. It still says it has not run yet. But now if we go back to our Cloud Run service, we should, hopefully things worked. We should see some logs.
And yeah, the service is supposed to run every minute. The way we define the Cloud Scheduler cron pattern, that we should be seeing it. Yeah, it's there.
Yeah, but yeah, when I click on Run Now, I was hoping that it would run. Yeah, so you can see that things are working. So these are the file names. Yeah, we downloaded them, then created the collage and then uploaded it. So let's take a look. So this will be in thumbnails bucket. And you can see that I have 5 pictures now, and this collage is the one that's been uploaded now. So we take a look at that one. Yeah, you see that it's the 4 pictures I uploaded, and they're just put together.
Woohoo!
Yeah, it works. Cool. Yeah, and then we tested the service. It works. Nice logs. It's good to have logs. That's it. So I will pause here and just see if people got it working. If you got it working, please post something in the chat so we know that some people finished. If you're stuck, let us know as well so we can try to help. and we'll probably pause for like a couple of minutes because we have 1 more hour, but we only have 1 more lab left, so we have plenty of time. So we'll pause here for a minute or two.
The magic commands worked.
Yes,
It's
copy
true.
paste.
Yeah, we have to look up the documentation because those commands are really not straightforward or obvious to like remember them by heart. So yeah. So that's why we would like to see something like what we have in Cloud Functions when you just say, okay, reply to or respond to an event, etc. So if you could have the same thing for Cloud Run, say, okay, I want to be pinged every minute, or would be nice.
Right.
So yeah, at least 3 persons managed to do it. So that's cool.
Good.
Yeah.
By the way, since the code is public on GitHub, if anyone wants to improve the code or add new features or something, feel free to send a pull request, and we'll be happy to take a look and see if we can merge it or not.
And we even had a pull request yesterday. So one of you suggested a quick change that was a typo somewhere in the README.
Oh, cool.
Any suggestion is great. Any improvements is welcome.
All right. So I guess I'll stop presenting here, and then Guillaume can take over from here.
Okay. Up. Presenting. Okay, present. So three labs done already. So we finished this one, running containers on a schedule. And the last lab will be using App Engine this time. So we saw Cloud Functions, we saw Cloud Run, and we're going to end with App Engine, which is not ironic, but in a way, it's not in the. If you look at the timeline, App Engine is the first serverless product, serverless service that we released 10 years ago. So it wasn't even called serverless because the term didn't really exist. But it was, well, there was an acronym that was PaaS, Platform as a Service. But let's have a look at what App Engine is, what it offers. So Google App Engine. If you look back at this spectrum of the serverless offering and compute options, let's say, so it's in between containers and functions. So the unit of work, we're going to deploy applications, but you could also deploy smaller units that would be functions. But yeah, you deploy applications on an App Engine runtime. So it's not a container where you can run anything. So it's a set of, I'm going to list them in a few slides. It's a set of runtimes that you can choose from to run your application. And you really deploy an application. You deploy your source code, or for example, if you're a Java developer, you can push jar files, etc. But it's really code or compiled code that you push. So what is App Engine? So it's serverless, but it's generally for a whole web application and not just single functions. Although, to be honest, I have some, for some of my personal projects, I have some GitHub commit webhooks that are functions, basically. And I was on Cloud Functions, didn't exist at that time anyway. So I'm actually using App Engine for some commit webhooks as a function. But yeah, the idea of App Engine, instead of focusing on the infrastructure, we let developers focus on the code, and Google Cloud Platform handle the rest. That means it takes care of scaling, networking, etc. So you don't have to be, an expert sysadmin or anything of that kind. You're a developer. You have an idea. You develop your application locally, can test it locally, and then you can upload it and push it on the App Engine runtime. Other quality attribute, it scales very quickly. So, for example, I was thinking about it the other day because of all the things we're seeing around the COVID-19. Sometimes you see let's say on TV during the news brief, they mention, oh, there's this application or this service or something. And then, well, it's not just related to COVID-19, but sometimes when your application is mentioned or your website is mentioned on primetime TV, usually when people watch TV and go to the website, they're going to see, 404 or 500 errors or things like that, because usually they don't really need to scale. They handle little traffic, and that's fine. But here with App Engine, the scaling, like with functions and Cloud Run as well, the scaling is very quick, very fast. And even if there's a peak of visitors coming to your website, to your application, it's going to scale very, very quickly. The runtimes are open source. They offer an idiomatic experience. There are actually two, I have a table showing that later, or even three flavors of App Engine. The first generation and second generation of App Engine Standard Edition, let's say. And there's also the flexible version of App Engine. Here, I'm focusing on the second generation because that's what is, let's say, used the most. And on this second generation, you can use any library extension or binary module or framework that you want, as long as it runs on the available runtimes. And the available runtimes are Python, Java, Node.js, PHP, Ruby, and Go. 2, 4, 6. I thought we had 7. No, that's 6. Yeah, correct. And here are the versions. So 3.7 for Python and 3.8 is in beta. Java 11 was released around last year. Node.js 10, but 12 is in beta. PHP 7.3 and Go 1.12. I think the version numbers there should be correct. We also have App Engine Flexible, which is a little bit closer to what Cloud Run is doing, except it's doing it on VMs. It runs Docker containers. It runs containers that are designed by the software engineers working on App Engine Flexible. But you can also run a custom Docker container, similarly to Cloud Run, except that it's based on VMs, so it's not scaling the same way. And if there's no usage of your application or website, it will be costing money because there will be some VMs running continuously. Whereas with App Engine Standard Edition, first generation or second generation, they run only when it's needed. Your application is scaling to 0, from 1 to 0, as well as from 1 to n, or infinity, or perhaps not infinity, but at least quite a number of instances. When I'm doing load testing, I rarely manage to go beyond a few hundred instances. So I'd need several injectors to get to the limits. I'm not sure if it's the same. So I got the question in the chat earlier about Cloud Run instances. I don't know if there's a quota of 1,000 instances. Perhaps that's the same kind of quota as on Cloud Run. I'd have to double check. So if you put everything into a little table, another thing I didn't mention, we said flexible runs on VMs, whereas on App Engine Standard, it runs in some kind of sandboxed processes, which run on Google's own Borg infrastructure, which was what inspired Kubernetes afterwards. The other difference I'd like to make between first generation for the old runtimes, the newer runtimes are all second generations, but the first generation was coming with built-in APIs. For example, there was a user API. There was a memcache API to do caching. So those APIs were coming built in the SDK, the runtime that you were using. Whereas with the second generation, you have to use the Google Cloud Platform APIs directly, and they are not bundled anymore within the runtime. So sometimes we called that, for the first generation, batteries included, in the sense that those services were already provisioned or part of the runtime. There were also some limits on the first generation in terms of some of the things you were running. Let's say some runtime APIs that you were using. There were some limitations. For example, so I'm a Java developer, so I'm going to mention Java here again, but the Java runtime, Java 8 runtime, which was something in between the first and second generation, prevented you from using certain classes of the JDK, the Java Development Kit. Whereas with the second generation, there are no such limits. You can even run binaries. So you could push your code, your application, but also, for example, the previous Cloud Run service that we use, or the functions that we created, were using ImageMagick. But you could also bundle ImageMagick with what you push to App Engine standard as well. So yeah, that's about it about the differences between those flavors of App Engine. But mostly we're really focusing on the second generation. Where's my cursor? It's here. The second generation, because that's the latest runtimes with the latest up-to-date or latest generally available, or what is it called, LTS, long-term support versions of those runtimes. For example, for Java, we stay to Java 11 because Java, I think that's going to be Java 17. That's going to be the next long-term support version. So the next big Java version might be Java 17 or something like this. All right. So where App Engine is a good fit, or what are the constraints? So App Engine is really a great fit, in my opinion, for web apps, backends for your mobile application, etc. That works really well. Any stateless application that needs part of the constraints, obviously, for which if you're using the right runtime, right? So if you're using a different language that is not part of the supported runtimes, well, App Engine won't be a good fit for you. So the scaling works well. The another aspect that I like is the CDN static asset serving. So if you, for example, if you have a web application, progressive web app, or something like this, and you only have the front-end code which calls the backend API within your web application, within your App Engine application, all the static assets like the HTML, JavaScript, CSS, etc., can be served as long as you describe it properly in the configuration file. You can say, okay, those assets are static assets, so they should be served automatically by static asset serving via a CDN. So it means that even if a web browser accesses the web application, it doesn't mean that there's already an instance of your application running. So that's interesting, as the CDN, for example, serves the static assets right away. You can see the web application loading, and then you ping the backend to load the data, for example. So that's pretty powerful. And the fourth Collab that we'll be doing is doing that, basically, because the JavaScript and the code from the HTML, injected in the HTML, is actually calling the backend API from the application, but the static assets, HTML, CSS, and JavaScript, is served from CDN or from the cache once it's in the cache. And yeah, about other constraints, yeah, so you have to have and use the right language, right runtime that's supported. And for flexible, yeah, the flexible flavor, you have the Docker constraints, if any. The scaling might be a bit slower to go up and down, and there's no scaling back to zero. And also the deployment times are pretty slow. I haven't used Flexible in a while, but usually App Engine standards, you can deploy your application in less than a minute, 30 seconds, between 30 seconds up to a minute or so, if it's a bigger application. But for Flex, it was like 5 minutes or something like this for even just a hello world. So that's why I wasn't super happy. So there's a question from Julien. We need a billing account. Oh yeah, for the second generation engine, we need a billing account now because it's using Cloud Bill for building. So even if you're within the free quota, because you can run, I forget what. So on App Engine front-end instances, as they are called, you can run 28 hours a day. It's weird to say 28 hours a day, but if you have multiple instances, you can serve more hours per day, basically, than there are hours in a day. But yeah, the second generation require Cloud Bill, and Cloud Bill also has a free quota, and I forget, it's in number of minutes of build. I forget the exact unit. I'd have to double check what the documentation says in terms of quota. But within that free quota, that means that your credit card won't be billed because you're within the free quota. For instance, my own personal blog, my web blog, has been using, it's been built with App Engine, and it costs me, well, actually it costs me a few cents a month because I didn't clean the logs, and I've got too much logs in terms of quantity. So I pay for my weblog a few cents every month. But I think Google Cloud doesn't. I've never seen my credit card debited for just a few cents. Anyway, so yeah, 120 minutes. Thank you, Julien. So you'll answer your own question. That's great. Awesome. Yeah, next. So I'm here. Why we choose App Engine? Yeah, great for. Oh yeah, something we didn't mention. You also have custom. You can use custom domains, but like Cloudrun, you also have TLS termination with nice URLs. So it's pretty handy. So you don't have to do any access by IP address, etc. So you've got a name that you can point at. In terms of concurrency and scaling, so it's similar to Cloudrun, and I think it's 80 concurrent requests like Cloudrun. You can get some cold starts, but much less than Cloud Functions, because Cloud Functions, there's a concurrency of 1. So if there are several clients calling into Cloud Functions, you quickly spin off additional instances. But for App Engine, so it's a function of CPU use, number of concurrent requests, etc., before it spins up a new instance. Another thing that's nice, that's the traffic splitting across version. So you can deploy several versions of the same application. So you can do things like A/B testing, blue-green deployments, or you want to let perhaps the QA team do some tests before you promote this revision, this version, to be the new one. And you can, what's nice is that you can put a cursor, basically, okay, you want to serve like 1% of the traffic at some point to this new instance. And you've got dedicated URLs. If you don't want to serve traffic right away to incoming users, you can point at a specific URL that says, okay, I want to reach this particular version of my App Engine application. And then once you're happy with that, you can do the traffic splitting and add a bigger percentage, 1%, 5, 10, 50%, etc. All right, so it's time to get back to coding. All right. So lab 4. So in lab 4, we are really going to build this UI, okay? So lab 4, the overview. So now you can see the complete picture of the architecture diagram. So the front end is here. Before we were manually uploading pictures through the cloud storage UI, but now we're going to have a web front end hosted on App Engine that's going to push pictures directly to our App Engine application. I'm going to use, and by the way, I hope the font size, may be too big, or at least it's not too small now. I'm using a small CSS framework called Bulma. So it was for doing this UI, the cards, the menu, the banners, etc. Because I'm not a very good front-end developer, so I like to use CSS frameworks that help me with doing something a little bit nicer on the eye. I'm also using a tiny bit of the Vue.js JavaScript front-end framework for the UI. So for I'm actually calling the backend API of my App Engine application to fetch the list of pictures, and that's the JavaScript of Vue.js called implemented with Vue.js that fetches those pictures. So as you saw, if I go back here, there are really 3 pages. So the main page here, where you can see the picture with the thumbnails, the labels, etc. There's the collage page, where you're going to see the collage of the 4 latest pictures, and then an upload page where you can select a picture and upload it to cloud storage. So we'll have a look at how these controllers or endpoints have been implemented. So let's go back here. So that's the results. So the 3 tabs, the home page, there's an index HTML page for that calls, thanks to Vue.js, with an AJAX call, the backend URL /API /pictures. I'm going to use this to highlight. It's going to be easier. The collage page, another HTML page that loads the collage PNG from the thumbnails bucket, the one that we generated in the thumbnail bucket. And then we have the upload page, upload HTML, that sends a post request to the same URL as the get request, API pictures, to post the picture. So let's move on to the next step. So that's where we explain again that you need a project, that you can launch Cloud Shell, etc. And here, that's where we say you can clone the code, but you should have done that already. So again, this is the URL on the GitHub project, to which you can contribute any improvement that you want. So within the GitHub project, so we saw the services directory, the functions directory, and there's a front-end directory which contains our code. So there's the let's say the web front-end part here. So it's actually my static assets. So that's the index, collage, upload pages. And I also have the JavaScript code, which is using Vue.js and some styles. I'm not sure I'm using the styles because I think I only used the Bulma CSS. Or perhaps, yeah, some style for the border around the pictures, I guess. And then here, that's the backend code, which is using Node.js again. So the index and the packages, and app YAML, that's the app engine configuration file. We'll have a look at all these. Yes, so that's what I explained. So let's have a look at the code. I'm going to move to my Cloud shell. So I in the shell down below, I moved already to the right directory. So Serverless Photo Sharing Workshop, that's the name of the GitHub project. And Frontend, that's the where I'm hosting my where I have the code of my App Engine application. So what do we have? As we said, the public assets are here. And what are we going to have a look at first? Let's have a look at, let's say, package.json. Okay. So it's pretty similar to the other products that we used. So we have Firestore to get the list of the pictures, storage to here we're going to upload a new file to the uploaded what did we call uploaded pictures bucket. Express, that's the web framework. Date.js, so it's used in the API, but it's not displayed on the web page. But it's for creating nice readable dates, like 3 days ago, 2 hours ago, etc. Bluebird, that's for promises. And I also use a middleware, an Express middleware, I think that's the correct term, for doing the file upload. So let's have a look at, so should we start? I think I'm going to start with the index.js page or app YAML. Yeah. No, let's have a look at the App Engine configuration first, and then I'm going to move to the Node.js code. So here, that's where I'm actually saying this application is using Node.js, and we're using Node.js 10. What's interesting with App Engine versus Cloud Run, within Cloud Run, you would define your Docker file and say, I want to use this particular base image. But if you don't redeploy on a regular basis your container, you might be stuck in a way with a particular version of the Node.js 10 runtime. But if there's a security vulnerability that's been discovered, as a developer, that's your responsibility to fix that and use a newer version of Node.js, of the Node.js Docker image. Whereas on App Engine, it's actually the Cloud Platform team that's taking care of updating under the hood transparently the version of Node.js that's being used. Same thing for Java, etc. We automatically update the version to the latest trusted version of the runtime. Also notice that we're going to, I think I have to update these later on in the, I have to remember to go back there because I already changed this, the environment variables for my two buckets, the thumbnail buckets and the uploaded buckets. I have to remember to change them because I changed them already from when I rehearsed this this workshop. So now let's have a look at index.js. Let's do this a little bit. So here we require all those dependencies that we needed, plus some built-ins like the path and the path and Express are path is built in. It's part of Node.js. That's for the file path manipulation. So that's something we're doing here. Then this part here, we're going to create our Express application, and we're going to say, okay, these. Actually, it reminds me that so I'm serving the static content from the public folder, but I wanted to check the App Engine configuration because that's where you can say, okay, this static assets those files or directories are part of the static asset. But I think I should add that to the configurations so that App Engine automatically put things behind a CDN, etc. So I forgot to do that there in the App Engine configuration file. Anyway, what's nice is that the Express static handling is going to do things like cache control and so on. So it's going to be cached anywhere by the web browser. And then the next step before taking care of the API itself, that's the file upload middleware here. So we're saying, why there's a double E? Oh. I'll have to check. Is it me who wrote the I, or is it in the on GitHub? We'll have to double check that. So there's a single I, and it says, okay, I want to limit the size of the pictures to 10 megabytes. That should be sufficient. I want to use temporary files, so that means I'm going to upload the file temporarily to the TMP folder, and it's actually an in-memory folder. Oh, so the typo is in the GitHub repository, so we'll have to fix that. And you can do pull request if you want. It's an easy one. Next, so we're going to look at this URL. So post/API/pictures. So that's the URL that's called from our upload page. So let's have a look at the upload page. So the upload page, well, there are some metadata, etc., some header, the navigation bar, and then here you're going to see that the upload page, there's a form method post to /API/pictures, and the encoding type is a multi-part form data. So there's some CSS and such. Choose a file here, and then there's the submit button. So when someone goes to the upload here, you hit choose a file, you choose a new file, and you click submit. I'm not going to do that now. And it's going to call the API/pictures. So what is this endpoint doing? So it's going to look into the request, the incoming request. So this bit of JavaScript is actually checking that there's a files property that's added by the Express file upload middleware. And if there's no file uploaded, for example, someone tried to hit that send a post request without uploading manually, like with a curl call or something like this, and forgot to put the file, it's going to reply with a 400 400 error code. Otherwise, okay, it's going to say receiving the file, and the name of the field input file here, the name of the field, it's tag file, and it's called picture. So that's why we have picture here. That's the name of the input field, of the file input field. So next, we're going to resolve that path to a local path. So we're going to upload the picture locally in the in-memory file store to /tmp, the folder /tmp, and the name of the file. And then we're going to use the Bluebird promisify method because the upload middleware, Express middleware, is not very async wait friendly again, like the other day, like yesterday with the image magic. And there's an MV command that you can use to say, okay, I want to move the file that I'm receiving from the web, basically, right, from the form that's been uploaded, that's been submitted. I want to move that file to this path that we created. And then, okay, file moved in temporary directory. So it's locally in memory in that directory. So next, we're going to say, okay, I want to store this image in the bucket pictures. pictures bucket. So that's what we're doing, upload, and we're awaiting on the upload code to say, okay, I want to upload my picture to cloud storage. I remember having to use resumable false, because if I don't use resumable false, you might get sometimes some weird errors. I forget the exact details, but it's better to use that. And once a picture has been uploaded, I redirect simply to the home page. Okay, next thing, that's this one. After post API pictures, we have get API pictures. So that's where we're going to retrieve the files, the pictures from Firestore. So we say, okay, I want to get the pictures within Firestore, the pictures collection from Firestore. We're ordering them by creation date, by descending order, because we want to have the latest picture being displayed first. So if there are no pictures, okay, we're going to log that. And otherwise, for each of the picture, we're going to, so I have a collection here, a list of the nails, and I'm going to push what I get from Firestore. So I've got the ID of the document, as we said, it's the name of the picture. I have the labels, what's in the picture. I have the color for the nice color border around the pictures. And then, although I'm not displaying it, I have a friendly date, 3 days ago, 2 hours ago, etc. And I'm logging this. You'll see that in Cloud Channel when we will run that. And just to show you the index HTML page. So again, the hero, the navigation, etc. And at the bottom, actually, you see that I'm embedding some app.js frontend Vue.js JavaScript code. We're going to have a look at that. But here, that's where I'm displaying the pictures. And you're going to see things like V4 and some math formula. V4, another V4, that's for actually, let's say, calculating the position in the rows and in the columns, so that I know when I have to do a new column or a new row on the when I display, so I can go through the list of pictures and create columns and rows appropriately. And also you'll see this one, a column style. I'm going to use the picture color from Firestore to add the border around the picture. And I'm using an ahref link to point at the picture, or well, for when you click on the picture, it's going to lead to the full size version of the picture, or well, not or, and of course, the image that you see on the index HTML page, it's the one from the thumbnails. Notice those URLs will be seeing that they are also calling our backend Node.js code. So this is API/pictures, and the URLs I just mentioned, we're actually doing some simple redirection. So the front end is going to say /API/picture/ the name of the picture, but under the hood, it's just going to redirect to the public URL of the picture, of the thumbnail or the full size picture. But that way, I don't have to pass to the view the name of the bucket. So it's kind of transparent. So that's why we have pictures and thumbnails URLs. And for the collage page, collage HTML is here. So it's also a simple page, navigation, etc. So here I just have a container that shows a figure, and the figure contains the image coming up from that endpoint here, and which points directly to the collage PNG that we generated with the Collage Cloud Run service. And next, we are saying, okay, by default, run on port 8080, or use the one provided by or asked by the the runtime. And then we listen to that, and we run. We can run locally. What I didn't show you, so style, I don't think there's anything in the style. Yeah, so that's just the size of the border around the picture. And the other thing I didn't show you, that's the here the Vue.js code that we embed in the index HTML. So it's just saying that, okay, I want you to know that this part of the front page is actually a Vue.js application. At first, the list of pictures is empty, but when you, so it's called mounted. So when the page is loaded, when the document is mounted and is ready to serve, it's going to make an Ajax call. I'm using a library called Axios that does Ajax calls. I'm going to call the API pictures endpoint to get the list of the pictures, and then it's going to go through the index HTML code here. So the v4 pick in, etc., and those things that I explained earlier. That's Vue.js that's going to populate those things and create as many divs and image tags, etc. Okay. So that's about it for the explanations of the code. So let's now run that. So, well, I'm just gonna re-export the names of the buckets, but they should be there. But just in case, let's ensure that we have them there. So my 2 buckets. So I said that I need to update something. So echo, I'm gonna echo them just to show you that they are set. And I'm going to use that to update my, oops, what did I do? My app.yaml, because I'm going to need to update these. So there's a, oops, that's the wrong one. In the Collage instructions, there's a magic command. I've already changed those bucket names in the configuration file, but I'm going to show you that there's a magic sed command that you can run to change there's a placeholder Google Cloud project there, but I had already changed it, so that's why I'm doing this here. And echo the other one, bucket pictures. If I forget the dollar, I'm going to put that correct. Oh, the correct URL here. No, this one. Okay. Okay, pictures, workshop test 1. Thumbnails, workshop test 1. Thought it was called uploaded pictures. Let me check just to be sure. I think we call it uploaded pictures. Buckets, in the list of buckets, uploaded pictures. Yeah. So let me change that. It's uploaded pictures. Workshop. So that's the convention that we use. All right. I'm going to do npm install to install the dependencies. So let me show you a bit more of Cloud Shell. Npm install. So it should be installing everything, all the dependency. Okay, dependencies are ready. In the next instruction, well, it's easy. I just need to npm start. And as you shall see, it's going to, start locally. Unlike in the previous labs, actually, we are able to run this and see that it works locally. What's interesting within Cloud Shell is that, so we're running in a VM on Google Cloud, but here, from within that VM, we run the application and we open port 8080. But there's this in the upper right-hand corner over there, there's this web preview button that you can use, preview on port 8080, and you can open it, and it will show you what the application looks like, right? So it's fully working. The collage that's been generated. So it was a funny picture about the scale of Scoville. That's how hot peppers can be. And I can even show you that I can upload a picture. So some more picture from my vacations. Let's say, I don't know, what do I have here? Yeah, a lake. Submit. And it's gonna do everything that it's gonna do once deployed on App Engine, but here it's really running locally on my VM, on my Cloud Shell VM. It's taking a bit of time. Should I worry about that? We'll see. The picture is not that big, though. Perhaps is there? Oh, there's an error. Yeah, on the logs when you were seeing console table that's printing this. Or what is it saying? Unhandled promise rejection. Not quite sure why it's doing this. Let me try again. That's weird. I have no idea what's going on. Is it doing it again? Oh. File and temporary directory. Okay. Content line 170. No, that's the one. Oh yeah, that's the one built. I'm not sure what's going on. Let's see if when I deploy it, it works. Otherwise, the rest is working. So you can see the collage, that's fine. You can see the list of pictures, that's fine, but it's just the upload that is not working. And I'm not quite sure why it's not working. Let's move on and see if the deployment works fine or not. Okay, so we did the preview thing. So deployment. So that's where, so in GitHub, and what you've checked out from GitHub, there's a placeholder here, Google Cloud Project, and there's a magic command that you can run to replace automatically Google Cloud Project with the name of your project. But as I explained, I had done the code lab before, and I had manually updated for my previous, for my rehearsal. So that's why I had the already different name for the buckets. So make sure to replace the name so that you have the correct bucket names here and there in the app.yaml file. All right. And then, yeah, we can say we want to stick. I think we deployed some stuff on Europe West 3 as well. So perhaps we're not consistent. Let's stick with West 1. And as I said, I think at the beginning I cd'd into the front-end directory. We're going to do gcloud app deploy. And yeah, what I like about, yes, I want to deploy. What I like about App Engine is that it's pretty fast to deploy. So usually it's within a minute. It can be potentially a bit longer if you've got lots of dependencies that are going to be fetched by Cloud Build to build your application in the cloud. But otherwise, that's usually pretty fast. So let's see what it's going to do. You should be seeing something like this going on. And in the App Engine, I didn't open it yet. So let's, so that's the one that I had running locally. I'm going to open the App Engine dashboard here. So it's still deploying. Yeah. I would say it's more than a minute this time. I'm just being too impatient, I guess. Updating service done. So now it's going to do the traffic splitting to say, okay, serve the the traffic via this particular instance that we've just deployed. But you can also add different flags for saying you want to deploy this version, but not promote it so that you don't serve traffic right away. You can do that. So App Engine, now it should be, if I reload this page, workshop test 1, yeah. App Engine. Yeah, so there's a version that's been deployed. That's great. I have the default service. Yeah, something I didn't mention about App Engine. You can also modularize your App Engine application. Compared to, let's say, something like Cloud Run, when you're scaling a Cloud Run application, you're scaling the whole application, the whole service. Whereas you can modularize an App Engine application and split it into different modules or services. It was called modules before, but let's call it services. And you can have several services deployed for the same App Engine application, and services that do different things. And the services are going to scale differently. So potentially the front end is the one that is used the most. So it's going to scale to, I don't know, 100 instances, but perhaps the backend API, I could have split the front end and the backend API into two services, two modules, and perhaps the API is used less, so it would scale to a lower number of instances. So that's interesting because it's more fine-grained in terms of the scaling behavior of App Engine, because you can modularize things into services and have different scaling, not artifacts, but scaling properties, let's say. So if I click here, now I should have my application showing up. I'm going to increase the font size. Okay, so this time it's really running. I'm going to show or zoom in here. It's running in Workshop Test 1, the name of my project, and in the Europe West region, appspot.com. I think you can, before an App Engine, you would only have this, but it's going to, yeah, it works the same. So there's a new regional URL, because you can also deploy App Engine to different regions. So you can see the pictures, all right? You can see the collage that was made every minute. Let's see if uploading a picture actually works. The lake thing, okay, submit. Yes, it worked, and I was redirected to the front page. But there's all the functions and Cloud Run services that need to run asynchronously. So when I'm redirected to the front page, it won't show me immediately the new image. But if I reload now, it should be already done, and I can see the lake. If I click on the picture, I'm going to be redirected to the complex URL here, and I can zoom in, etc., for the full size picture. And what else should I say? Water, sky, lake, etc. And the collage, let's see, it's been updated. Not yet. So the collage, because it runs on the schedule every minute, it's going to be showing up soon, in a few seconds, hopefully. If I come back, a hard refresh. Yes, it's there. I have the lake. So I've got my little cat, the papers and everything. But it works. I don't know why it didn't work locally, but at least it works once deployed. And I have to figure out what's going wrong there. So that's about it. We deployed it. Let me show you a bit more of the console, the cloud console. So I deployed only one service, but I can have several versions. So currently there's only one version, but that's where you can do things. It's going I can click on split traffic with only one version. That's interesting. But I can't really do much with it because there's really just one version. But you can say, okay, I can split the traffic by IP address with a cookie or by random. And I can say, okay, this version serves a certain amount of traffic, and these other versions serve 80% of the traffic. I can see some information about the instances that are running, etc., quotas and so on. Things like memcache, cron job task queues. For example, cron jobs, it was built in. Cloud Scheduler actually was part of App Engine before, but we split it into a dedicated product. Yeah, so that's about it. So we deployed it, and it works, and we tested our application. So we've managed to do it all. One function, 2 Cloud Run services, and 1 App Engine web front end. So let me go back to the slides. I didn't check the questions. Hopefully, yeah, it's all handled up. So the something we'd like to announce here, I'm going to keep this slide for a minute, is that so we've done 4 code labs together, and we also have a different platform called Quick Labs for other kind of code labs. And there's a quest on Quick Labs where you have 5 code labs, 5 quick labs that you can play with. So you can enroll in this quest for free and do additional workshops on your own with dedicated accounts, etc. So feel free to copy and paste this URL and get it in your browser to claim this free access for Quick Labs for 30 days. And something I'd like to announce, so that was the first edition of the workshop, but if you've got friends, colleagues, etc., that didn't get a chance to enroll in this edition of the workshop, we're going to run another edition of the workshop on May 6th and 7th. We'll be tweeting like we did for this first edition. So feel free to share that information on when you see our tweets. We're happy to get some feedback from you. So for example, yeah, thanks for sharing the link inside the chat for the Quick Labs. Later on, I don't know if it's today or in a matter of hours or today or tomorrow, I don't know, you're going to receive an email. There's a link with a survey that you can fill. So if you have some feedback, if there are things that you think we should improve, ideas, etc., problems you encountered or things you'd like to see, feel free to give that feedback to us. It's very important. So I know that it's not easy to do a hands-on workshop virtually. It's usually easier when we can go, check what everybody's doing on their computer. Remotely, it's much more complicated, and we have to rely on you saying, hey, I've got a problem. So feel free to give us some feedback. We're open to feedback. Thanks a lot for your attention, and we have I think a few minutes left for extra questions. So thanks a lot for everybody who joined. Thanks again for all those who, all the communities, the GDGs, the meetups that shared the news about this workshop. Thanks a lot for them. Thanks a lot for you for joining. Be there on both days, and for all those who tried all those commands and try to deploy things online.
Yes, thanks everyone. And I also want to mention that we also have another version of this workshop next week. So if you know someone who couldn't get in here, let them know. We're going to have another session next week.
Yep. Maybe 6 and 7, same time, same time zones as well. Yeah. No question. So thanks again, everybody. It's been a pleasure to have you with us, and well, enjoy. So another thing we could mention again is the credits that you have. I think you've not used them at all for this workshop, so you still have the pretty much or likely all of the $40 of credits. So feel free to use any other tools and services and products that we have on Google Cloud Platform. And oh yeah, good question. Any chance to get the workshop with something else than JavaScript, like Java, Python, Go, for example? Since I'm a Java developer, there are chances that I'm going to try to do the another version of this set of code labs in Java. I'm waiting a little bit for one reason is that it's because I'm waiting for Java in Cloud Functions. So Java in Cloud Functions is in alpha currently. I think I can perhaps give a little scoop there, but normally next week or the following, if we're still finishing some samples and documentation, but next week or the following, we're going to announce the beta of Cloud Functions Java 11. And once there's Cloud Functions Java 11, I'll be able to do this code lab fully in Java. Okay, so I'll try to do it in Java. What forum channel are these addresses? Yeah, so that's the at Laforge or at Mete Atamel. That's our Twitter accounts. But if you want to ping me, my Google email, it's glaforge@google.com. On GitHub, well, everywhere I'm using Laforge, basically. So glaforge@google.com or Laforge on Twitter. That's a way to contact me. And Mete, what is it? It's Atamel, I think, for your email.
Yes, my email is just my last name, atamel@google.com.
Right. So feel free to ping us there. What other channels? I used to look at we have a Slack community, but I haven't used it. I haven't logged in there in a while, so I'm usually not very often there. But there's a Slack channel that exists, which is quite nice. You can get answers there. Other places where you can ask questions, it's on Stack Overflow. There's a Google Cloud Platform tag, and there are specific tags for App Engine, Cloud Functions, Cloud Run. They are monitored on a regular basis. I know I should do it myself more often, actually. So yeah, there are many ways to reach out. Thank you, Matt, for the question. And AR for other languages. Yeah, let's do that. And I need to encourage some of my expert colleagues, Python, Go experts, to do a version of those code labs in other languages. All right, thank you, everybody. We'll post the video later on. Not sure exactly when, because we're not sure exactly where we're going to put it. We're investigating which YouTube channel we can post that, but we'll share the URL with Twitter. So it's a way to encourage you to follow us. And yeah, that's about it. Thank you, everybody. And see you soon somewhere, and stay safe.
Yeah, see you.
Bye-bye.
Bye.